Hello. Okay, we found some, really nice um, LED multi-digit modules for I think $1.50 on AliExpress, and downloaded some specs, and then wrote a driver and used one of our development boards here, and we're going to show you how we work these little things. Okay. Here's some really nice 8-digit LED displays. You can get them in the 0.36 or I guess 0.54 or 0.56 height if you look around. They're all relatively cheap, and they run with the MAX7219, which is particularly easy chip to interface, and we'll get into that next. Well, here's the MAX 7219 specs that are on these display boards I got from AliExpress. Oh, they run up to 10 megahertz, which is most of the micros I use will never clock them that fast anyway. They can run either decode the digits themselves, or I like to do it just send them the segments. That way I can make anything I want out of it. Oh, they got a brightness control and other things here. They have a kind of a semi-SPI type interface with a few gotchas you got to look out for, but we'll get into that. So since I'm buying the whole thing, I don't have to worry about the pinouts because it's coming all assembled already. And what can we say about this here? The way you access this is kind of straightforward. You basically send 4 zeros, because you got to send 16 bits all the time, but these are never used. You send the number 1 through 8 to tell which digit you want to address, and then the data for it simply goes here with the D7 being the decimal point. Now it's actually in reverse order of the typical 7-segment display, but we'll get into that. Yeah, and then there's it's very consistent here. The first 4 you don't do anything, and then the next 4 you've got a no-op one here, which is handy if you're not doing anything. Other than that, you send it the number 1 through 8 in these positions, and then the next byte is the data that's going out there. You can also set the decode mode, intensity, scan limit if you're running less than 8 of them, shutdown, which is really a way to turn it on, and I haven't used the display test, so yeah, I like the no decode mode. None of these seem to have defaults. So it's not that these default to all zeros. It's got to explicitly. When we get into the code, we'll show you that. Here's the way they decode the segments, but I don't use that. I'm making my own. Here's the thing about this. In a normal 7-segment display, A, B, C, D, E, F, G are positions. The low order one is A, and they're using the low order one as G. So you have to make sure you do the pattern that way. And the decimal point's still in the high order bit. And when we get in the code, we'll show you how we did that by setting up the tables, all kinds of brightness, things like that there. And someplace in here it shows you how to run the, we're going to skip some stuff here. Oh, yes. Okay, there's one extra gotcha in doing this. When you bring the chip select low, and then you start clocking in the bits with the rising edge of clock, real easy to write in code. The thing is, for the last one, you have to, after you've clocked in the last bit, you're required to do one more clock. And what you have to do is set the chip select high, which is also what's called a load, and then do one more clock. and we'll show you how that looks in the code. So you send a total of, well, for all the bits, you send 17 clocks altogether, with the last clock is the one that really latches it in, and it shows the tricky timing things here. Okay, here's our software driver we wrote. We're on version 103 right now. For the ATtiny84, pins, set the pin assign. Instead of doing a bunch of defines, the enum is very handy. It starts 0, 1, 2, 3, 4, and 5. An easier way to set a bunch of those. Also, the commands for the 7219 chip. When you do an enum, you can set the first one with an equal, and then this is 10, 11, 12, 13. So this is handy to set all those without, again, a bunch of defined statements. Here's our segment data that goes 0 through 9 and A through F, so it can go up through hexadecimal. You just kind of, I diddled these out because the assignments are in high order first instead of low order first, or maybe it's the other way around. Anyway, they're backwards of how you usually do those patterns. You do a certain initialization, and then I was sending out the digits 8, 9 through 15 to show the hexadecimal ones here. This is just a utility thing that likes to outdeck. Okay, this is the output routine. Figures out how to put the decimal point on and how to do leading zero blanking. But here's the init. Before you do anything, of course, I have to set these 3 lines, the clock to select, and the inputs to output here. Then the decoder, like 0 intensity, I've got most of the way up. Scan limit 7, which actually means 0 through 7, so it's all 8. The shutdown is 1, which means it's on rather than off, and I got my own blank routine which blanks 1 through 8 just to give it a nice clean start. Here's the main routine. Now, let's see. How you form the command? There's an operation and a data byte, and you just shift the operand to the higher byte and put it in a 16-bit or with the data, and that makes your 16-bit command. Now, you start it out just like a lot of stuff. You lower the chip select active low, and then for the 16 bits, the reason the clear for the clock is here instead of usual set and clear down here is because we have to end with a set, and we'll show you that. So it starts with the high order bit, and clear port. Yes, starts with the high order bit, and then sets the in either high or low, and then the rising edge of the clock sets it in, and then we shift the data 1 left, so it's high order first. Now here's the trick. This thing needs to end on the clock high, because the specs say you have to now set the select back high and then set the last clock low. It's in the timing diagram, so that's how that works. So that's how we're doing it here. Well, here's how it looks running. We got our code tapper 3, which is a ATtiny84 board, USB in, and some lines coming out. We want to just run something. We just hook it up to the pins, and here's our display. We start at 8 and go up through F. Oh yes, the lighting, and then maybe we can adjust something here. Okay, so there it goes. Hope you find this useful. We're going to try to load the actual source listing on our GitHub page. Look for the link in the comments below, and have a nice day.